This is Mr. Tapia, and you're watching a video on solving right triangles, and this will be part 1 of the video. So before we get started, the first thing that we really need to understand are the parts of a triangle, and as you can see we have them here. The first part that I want to kind of draw your attention to is the reference angle, and I'm going to go ahead and change the color. So we have this thing right here, and that is the reference angle. The reference angle pretty much tells us whether one side is the adjacent side or one side is the opposite side. The easiest part of any right triangle problem is always identifying the hypotenuse, because it's always the longest side, and as you can see, this side here is the longest side, and so we can go ahead and label that the hypotenuse. Now if you look at the reference angle and you bisect it or cut it in half, and let me show you what that means. So if you took the angle that it gives you, which is right here, and you cut it in half, so if you took a line and you kind of drew it and cut it right down the middle like a slice of pizza, the side that it would point to on the other side would be the opposite side. So if you have the hypotenuse and the opposite already labeled, the only thing that you have left is the adjacent. But for definition's sake, the adjacent side is the side closest to the angle that's not the hypotenuse, okay, and not the longest side. And so as you can see here, we have the adjacent side here, and then we're ready to get started. So as you can see, we are given some information from this problem. We're given some information. We have the reference angle, so we know that our angle, which we identify as theta, is equal to 20 degrees. We have our adjacent side, which is equal to 7, and we have our, and we're looking for this side right here, the hypotenuse. Now, there's a really good mnemonic device for memorizing the rules for solving right triangles, and basically it's just SOHCAHTOA. So, when you look at the problem, you essentially know that you have an A right there, the adjacent side, and you have the hypotenuse. Well, there's only one of these that has both of those in it, and that it is this one. And so the rule is cosine of theta is equal to adjacent A, which is 7, okay, so that which is adjacent over hypotenuse. And from here we can just kind of fill in the blanks. So as you can see, we have the cosine of theta, which we know that our angle here is 20 degrees. We can plug that in. And we have the adjacent side, which is 7, over hypotenuse. And we can I'm just going to put an H in the spot for hypotenuse. So I guess the question here would be is how do we solve for the H? Well, luckily we're never really expected to do these without a graphing calculator. Alright, so you're going to turn on your calculator. First thing you're going to do is go to mode. And you're going to make sure that you're in degree mode. This is degree mode right here, not radian mode. And so you go down, go over. The programming, the setting is the same for most other TI calculators. So you go second, quit, and then you go back to mode to make sure that it's stuck. And it did, as you can see, degree is highlighted. Second, quit again. And now as you can see, we have cosine 20 is equal to 7 over H. And so using just algebra, we need to figure out how to set the H by itself. And so there's a lot of tricks we can employ here, and we can multiply times H, multiply times H. This is going to cancel out. We need to, so we're going to get H cosine 20 equals 7, and then we can divide by cosine 20, divide by cosine 20. This cancels out, and what we end up with is H equals 7 divided by cosine 20. So I'm going to plug that in the calculator. We get 7 divided by cosine 20. Enter. And as you can see, I got a weird kind of number because I didn't put the cosine 20, I put cosine 200. So let's try that again. That's better. So as you can see, you got 7.4, or let's say, 7.4. Alright, so as you can see here, we got the answer. Our answer is equal to 7.4. The question, too, you should ask yourself when you work any of these problems is, does the answer make sense? I have a really, really narrow number of degrees here, and I have a really, really long side. The longest side, which is my adjacent side, is 7. And so it makes sense the hypotenuse would be a little bit longer than the adjacent side, given how small the angle is. I hope you enjoyed this video. Thank you for watching.